So AI solutions have lots of different approaches, right? The flavor of the day happens to be data-driven machine learning, right? We throw a whole lot of data at a system and we can automatically learn new behaviors, classification techniques, things like that out of machine learning approaches to AI. It's not the only way to do it. There is symbolic AI and all kinds of other ways that we sort of go about this. But the flavor of the day is definitely machine learning. The problem, one of the problems with machine learning is that it is notoriously opaque. It is very hard to understand after you've gone through that process what that resulting AI system has actually learned from all of those data examples that it has been given, and what it hasn't learned, by the way, right? So there's classic examples in computer vision capabilities here where things sort of get a little out of whack. And you imagine that you are training, so a system that we work with, that we've been working on with DARPA is a smart camera system that can detect whale activity, right? In the interest of protecting marine mammals from all of our human use of the oceans. So one of the challenges that comes there is we produce all kinds of data of imagery and video that has whales in it, right? And it might be actual breaching whales with, you know, all of the fabulous whale watching, flipping tails and all of that. But often it's on the horizon and it's a small breach with a little bow, and it's really hard to see and understand sort of what's happening there, right? So we're building smart cameras that can do that. Well, if in doing that, we generate a data set to train that computer vision algorithm against that is incomplete, right? It doesn't include enough things that are whales and enough things that are not whales for us to have a lot of confidence at the end of the day that what we've generated is really a whale detector and not a whale and canoe detector. Right. As an example, right? The canoe, we didn't differentiate enough in our data set from the whale, and now our system thinks canoes and whales are the same thing, right? So there's all kinds of, and you wouldn't know that at the end of the result of the machine learning process. You would explore that and find that out in a validation and verification process, hopefully. But wouldn't it be nice if we could generate that system and then open up the black box and peek into it to sort of say, okay, given all the data that I gave you to train against, what have you actually learned and what have you not learned? So this is a whole field of research called explainable artificial intelligence, where basically we put AI systems into lots of interesting situations. And then we try to monitor and understand what they do well and what they don't do well. And we try to build narratives by poking at the AI and building sort of models of its behavior that will be explainable to a human user, right? At the end of the day, somebody is going to make a decision about what that AI is telling it. And if that AI is not trustworthy because we don't understand what it knows how to do well and what it doesn't know how to do well, we are compromising that human user's decision authority. Right. So this is a whole new field of research that is getting a lot of attention, and focusing on those kinds of problems with the way that we are really quickly putting AI systems out into the world, never forgetting that we have the obligation to look at those challenges associated with how they operate in the world.